Good afternoon. This is Wolf Kursten, and today I'm going to be talking about SAP HANA on the cloud. This presentation is an introductory understanding of in-memory database computing and specifically focusing on the HANA offering from the SAP software application provider. Today we are going to be talking about what is SAP HANA, why SAP HANA on the cloud, the SAP Cloud Platform, NFL Fantasy use case that we are going to be going through, as well as a library application that we are going to be talking about, and some of the key challenges associated with SAP HANA. So what is SAP HANA? SAP HANA is an in-memory database. All the data is stored in memory on on solid-state drives, and also typically this is done in a multi-core processor. And the interesting thing about this is it's an appliance. So both hardware and software is required, optimized for SAP HANA for this particular appliance. So let's just look at what traditionally happens. Typically what happens is you have a hard drive, a physical hard drive. This is where all the data is stored. And if you want to actually produce a report, what happens is the report needs to call the data from the hard drive. This goes into RAM, then it goes into some sort of cache, and then eventually it lands up in the actual report that's being produced. With SAP HANA, the whole process is that the actual data is stored in actual memory, and when you actually start calling data for a particular report, the multi-core processors just pull that data immediately out of memory. If you know anything about this kind of technology, one would know that typically 90% of the effort or the time taken to pull data from the hard drive in a traditional technology environment is basically pulling it off the hard drive, and then only 10% is actually processing it and producing the actual report. So with SAP HANA, this will actually cause those 90% to be reduced quite substantially. Let us just understand what SAP HANA has done. Essentially, SAP HANA has implemented a column database. So what does this mean? Typically, a traditional relational database structure is a row database. So when a particular set of data is written to the database as a record, it is actually stored as a row rather than a column. So, for example, in this particular instance, what we have here is a record of stock symbols, and these have been purchased for a particular price and of a particular quantity, and they belong in a particular industry. So if we want to actually store this data into a row database, then what it would do is just do one write into that particular database for each one of these particular records. Now, if you wanted to actually sum, say for example, the cost or sum the quantity, what you would need to do is actually do 4 reads for the 4 records, pull them in to memory, and then at that point what you would do is actually sum the cost and the quantity. So let's just talk a little bit about the column database, a little bit different. So what happens is when you write to the database, it actually goes along and firstly records every one of the stock symbols in a column as a record. Then it'll record the cost and then the quantity and then the industry. So when you're actually writing these or writing a record to a column database, it actually takes 5 inserts into that database to actually write one of these records. So, but let's just look at it from the other side, is if you want to read and, for example, want to sum the data, all you have to do is if you want to sum cost, that would be one read, because you're reading all 4 records, or all the data in that, the data for those 4 records are read immediately, and then the quantity is also read as one read. So as you can see, if you're using a column database, then from a reporting perspective and analysis perspective, it makes a lot of sense to use this type of database. It's optimized for actually reading versus writing. And if you look at the row database, it's basically optimized for writing rather than reading. And so typically a column database is used when doing analytical type applications, or when using analytical type applications. Also, another thing about the column database is it facilitates a far more efficient data compression. So what happens is, for example, let's take quantity here. You had 2 quantities of 50 units each, and in this case, what we can do is basically summarize for the 2 records, 2 and 3, we can summarize that into one field, because we can actually state that you have 2 50s and put that into one field. For example, with the industry in this particular case, you can actually summarize that into one field as well. And therefore, if you look at this particular diagram here, you can see that essentially 3 fields have been saved in this particular simple example. So in addition to not only taking out the typical type spaces when you're compressing, etc., etc., with a column database, you have some of these type of facilities as well to initiate a far more efficient data compression. So thinking about this from a memory capacity, there are still obviously physical constraints around memory, and so having highly compressed data will help to facilitate that type of in-memory database in terms of the volume of data that you can hold in memory for a particular server. So very important to have very efficient data compression. So let's just summarize. Data resides in memory, which increases the speed of access to data. Hardware with high RAM, multi-core processors, and solid-state drives are required. Also, it's an appliance, so certified hardware is used. This is, for example, comes from Dell, IBM, HP, etc. SAP has certified these to provide the hardware for SAP HANA. And as I mentioned, the column database architecture is used for high-speed access, efficient compression, concurrent processing, as well as writing, is really typically slower than most row-based. Let's just see how this has been used and how it's actually been evolving over time. Original version of SAP HANA was built to speed up analytics, as we can see and as we discussed now. So really optimized to make reads far more efficient. But today, SAP HANA is being promoted as a single database that can support both transactional as well as analytical processing. For example, you can see here in the diagram, with transaction-heavy processing type applications, for example, like SAP sales order processing or purchasing type systems, the write is extremely important, and therefore it would make more sense to have a row-based type, relational type-based database. And if you think of analytically heavy processing type systems like reporting systems and statistical type applications, it would be much better to have a column-based. So typically in a traditional technology architecture, you would have 2 databases, and you would need to keep 2 copies of the data, and on a regular basis, regular intervals, you would then transfer the data across from one database to the other. So therefore, actually analytical processing would not be in real time. What SAP HANA facilitates is the ability to just have one database, and the one database therefore only provides one copy of the data. Transactional and analytics is essentially real time because you don't have to do a copy at regular intervals, as well as, of course, the high-speed processing of such an efficient in-memory database facilitates very, very quick turnaround of transaction reads and writes. Here is big data. So this is another evolution that's occurred fairly recently with SAP HANA. And what we have here is data that's structured and unstructured coming from multiple sources. And this is typically, in this case, has been put into Hadoop and using some sort of map reduction like Hive. This would be then extracted out and then placed into an application for further analysis. What SAP HANA facilitates is the ability, number one, to extract that data out of Hadoop data store highly efficiently, and typically what is called hot data is put into SAP HANA for analysis. But on top of that, very recently, SAP has produced a new tool that's called Smart Data Access. What happens is SAP HANA is able to look into the Hadoop data store and not necessarily copy the data from the data store, but it actually just uses the data in there for the processing as well as whatever data is sitting in the SAP HANA database as well. So this facilitates even further the ability to speed up the processing. So this gives us a good understanding of what this is all about, and I'm going to now speak about why SAP HANA on the cloud is required, and that is in version 2.